In the 24th Minitab tutorial, we are in the die casting production facility of Smartboard Company. Skateboard axles are manufactured here by using two die casting systems. The central quality feature of the skateboard axles is the axle strength. Smartboard Company's customers require an average axle strength of 400 megapascals, plus minus 5 megapascals. As part of this training session, we will accompany the Smartboard Company quality team and experience how the corresponding quality control charts are used to analyze whether the die casting process can be classified as a stable process, in terms of the customer specification and in terms of the Automotive Industry Action Group Standards, AIAG. We will see how the quality team first uses descriptive statistics to gain an initial impression of the average process situation and process variation, before the actual process stability analysis, and then evaluates the quality of the process stability by using corresponding quality control charts. We will learn that different types of quality control charts are used, depending on the scale level and subgroup size. In this context, we will first deal with the scattering behavior of individual values and mean values, by using a simple data set in order to better understand the so-called statistical parameter standard error. We will become familiar with the so-called quality individual chart, also known as the I chart, the mean value chart X-bar chart, and the standard deviation chart, known as the S chart. For didactic reasons, we will also manually calculate the respective upper and lower control limits in the quality control chart step by step for better understanding, and compare them with the results in the output window. On this occasion, we will also use the so-called range chart, also known as the R chart, and also manually derive the corresponding control limits for this. We will then learn in detail the 8 most important control tests established in the industry, based on the Automotive Industry Action Group Standards AIAG, which can help us to detect any process instabilities. We will experience that if a quality control chart is selected incorrectly, there is always a risk that the control tests will react less sensitively to existing process instabilities. And in this context, we will also learn how an overall process can be divided into 2 subprocesses by using the useful function, form subset of worksheet. With the knowledge we have learned so far, we will become familiar with the so-called moving range chart, commonly referred to as the MR chart. And we will learn that the combined individual and moving range chart, IMR chart, is always very useful when individual values are to be compared with each other that are not summarized in subgroups.